Hello, everyone, and welcome to the 2021 3-minute thesis, ma thèse en 180 secondes competition. My name is April, and I am a Skills Development Officer at McGill University's Teaching and Learning Services. Over the past 6 months, I have been leading an amazing team who has put together this year's 3MT MT180 competition. This afternoon, you will see the culmination of our efforts as we welcome 15 fantastic competitors who will be sharing their graduate research with you in English ou en français in 3 minutes or less. When we started our planning for this event last summer, it was unclear to our team exactly what a competition in March 2021 could look like. Would we be able to do this event in person, on campus, online, with an audience at all? After much conversation, we settled on today's format, a virtual 3MT MT180 competition where finalists present live from their home directly to yours. While we all may be logging in from different places to join in today's event, I would like to take a moment to acknowledge and bring into our virtual space some qualities of the physical space on which McGill is located. McGill University is located in Tiohtià:ke, also known as Montreal, situated on unceded land in the traditional territory of the Kanien'kehá:ka Nation, who are recognized as the custodians of the lands and the waters which we use when we gather at McGill to teach, to learn, to research, and to create the knowledge that our presenters will share with you today. The Kanien'kehá:ka, also known as the Keepers of the Eastern Door, are one of the nations that make up the Haudenosaunee Confederacy here on Turtle Island, also known as North America. On my slide here, you can see North America outlined in the shape of a turtle, hence Turtle Island, with Tiohtià:ke, or Montreal, at its heart center. Tiohtià:ke is historically known as a gathering place for many First Nations. Today, it is home to a diverse population of Indigenous and other peoples, including over 10,000 McGill graduate students, from which our finalists today are drawn. In the spirit of today's event, where we will engage together in teaching, learning, and listening, I encourage you to learn more about the original lands and peoples of the place that you are joining us from, if you don't know it already. For those of you logging in from somewhere in North America or Turtle Island, nativeland.ca is a fantastic resource that can help you connect with the land you are on or have been on in order to better inform the ways you engage with both your space and your community. Now that we're all comfy and situated in our virtual space together, it's my great pleasure to introduce our Master of Ceremonies for today's event, McGill's Dean of Students, Professor Robin Beach. Over to you, Robin.
Thank you, April. Bienvenue, welcome. I'm Robin Beach, the Dean of Students, and I'm very happy to be hosting this year's virtual 3-minute thesis. I would like to welcome all of you joining us via the YouTube live stream to this afternoon's exciting event. Je suis très heureux de vous accueillir à la finale de concours ma thèse en 180 secondes. Je vous souhaite à tous la bienvenue et vous remercie de vous joindre à nous en si grand nombre. We have a straightforward order of proceedings today. Le déroulement du concours est simple. We will provide you with a brief overview of the competition history, the rules, the judging criteria before we begin the presentations. After the presentations, the judges will deliberate, and you can vote for the People's Choice Award using the link provided on the description of the YouTube video. Je souhaiterais maintenant vous donner un aperçu du concours, des règles, des critères d'appréciation avant d'entamer la compétition. Après la présentation, le public en ligne via la chaîne YouTube de McGill sera invité à voter pour le prix du public. Les résultats seront annoncés sur place après délibération du jury et après compilation des votes publics. A few notes for the audience today. You can access the virtual program of today's event by clicking on the link in the description box of the YouTube live stream. After the last presenter, when the judges leave to deliberate, there will be a short question and answer period for you to ask questions to the presenters. We encourage you to send in your questions for today's presenters by emailing to 3mt180@mcgill.ca. En terminant, je voudrais souligner quelques points. Vous pouvez accéder au programme de présentation virtuelle via le lien fourni dans la description de la chaîne YouTube de McGill. Après la présentation et pendant délibération du jury, il y aura une courte période de questions et réponses, où vous aurez la chance de poser des questions au présentateur. Nous vous encourageons à envoyer les questions par courriel à 3mt180@mcgill.ca. 3MT is a research communication competition developed by the University of Queensland in 2008. It's now an international competition. Le concours MT180 s'inspire du 3MT. Le concept a été repris en 2012 au Québec par l'Association francophone pour le savoir, qui a souhaité entendre le projet l'ensemble des pays francophones. Graduate students have 3 minutes and not 1 second more to present a compelling oral presentation of their thesis and its significance to a non-specialist audience. Using a single static slide, a member of our staff will be monitoring the time and the judges will be notified if anyone goes over the 3 minutes. Les étudiants auront 3 minutes pour présenter en français un exposé convaincant sur le sujet de thèse et sa portée dans un langage convenant à un auditoire composé par la personne éduquée, mais potentiellement profane en la matière. Pour accompagner leur exposé, le candidat et les candidates ont droit à une seule diapositive. The presenters are not allowed to use any props, notes, costumes, and the presentations must be spoken with no songs or raps. Aucun accessoire, autre que des feuilles de notes, costume n'est autorisé. Le discours doit être présenté d'une voix claire et ne peut être chanté. The judges will be selecting the winners based on these criteria. On the left, you can see the Canadian English criteria. Communication, was the talk delivered using pace, terminology, body language, and a slide that were easy to understand? Comprehension, did the speaker clearly explain the research they conducted, the results they found or anticipate finding, and the implications of their work? And engagement, did the speaker convey enthusiasm, hold your attention throughout, and make you want to know more? Les critères du concours français sont semblables à celles du 3MT. Talent d'orateur et implication signifie que le ou la participant transmet sa recherche passion pour son sujet étude, a démontré des qualités oratoires, une voix claire et assurée, rythme, fidélité gestuelle, présence sur scène et d'avoir fait partie intérêt personnel ou éventuellement de liens avec la société ou l'actualité. Vulgarisation. A-t-il ou elle expliqué les concepts dans un langage accessible, utilisé les figures de style, des exemples pertinents ou l'humeur. Finalement, la structuration de l'exposé. Est-ce que les recherches menées ont été clairement expliquées? L'enchaînement des idées ont-ils facilité la compréhension du sujet? L'équilibre entre différentes parties, introduction, développement, conclusion, est-il satisfaisant? It is important to note that the competition, the judges evaluate the presenters on how well they present, on how well they deliver the information, not on the research itself. This year, more than 150 students registered to participate in the presentation skills training and coaching sessions. After this, they participated in the qualifying heats, from which the 15 finalists you will see today were selected. The finalists then received one more round of individual training to prepare for today. All in all, they've worked tremendously hard to come this far. Before we see the students, I'd like to introduce you to our panel of judges and the prizes of today's competition. Cette année, plus de 150 étudiantes des cycles supérieurs ont pris part aux ateliers de formation. Ces ateliers avaient pour but de permettre aux étudiants de fonctionner leurs compétences et obtenir des conseils pratiques pour préparer leur présentation, et vue d'une présentation grand public des travaux de recherche. Par la suite, ils ont participé aux éliminatoires, puisque 15 finalistes que vous voyez aujourd'hui ont été sélectionnés. Les finalistes ont eu l'occasion de participer à une séance d'entraînement supplémentaire pour raffiner davantage leur technique de présentation avant la finale. Tout cela pour vous dire que nos finalistes ont travaillé très fort pour se rendre ici aujourd'hui. Avant de commencer, j'aimerais vous présenter les membres de notre jury multidisciplinaire. We have 4 judges this year who cover a wide range of professional experience and educational backgrounds. Professor Joe Schwartz is director of McGill University's Office for Science and Society, which has the mission of separating sense from nonsense. He is the recipient of numerous awards for teaching chemistry and for interpreting science for the public. Dr. Joe has hosted a radio show on science for 40 years. He's appeared hundreds of times on television, writes a regular newspaper column, and is the author of 18 bestsellers. He has been awarded honorary degrees by Athabasca University, Cape Breton University, the University of Windsor and Simon Fraser University. Professor Schwartz is also an amateur magician and often spices up his presentations with a little magic. Justine Perez-Smith is a freelance writer and film programmer. She has contributed to publications such as the National Post, the Globe and Mail, and Hyperallergenic, writing about art, film, and culture. Since 2018, she's been a member of the Fantasia International programming team and curates the underground film section. She is also the vice president of the Quebec Critics Association. Laura Weiner is the Director of Teaching and Learning Services at McGill. Before coming to TLS, she was at the Office of the Provost as a special advisor to the Provost, and she also spent 4 years in the Office of the CIO at the Senior Educational Technologist. She's taught in the faculties of education at McGill, Université de Montréal, and Concordia University, conducted research on educational and training applications of information and communications technology, and most recently in the field of medical education, and published or presented nationally and internationally on faculty development issues and integrating ICT into teaching and learning. Nancy Ross, as McGill's Associate Vice Principal of Research and and directs initiatives and projects that advance McGill's research enterprise across a variety of disciplines. A professor in geography and is an associate member of the Department of Epidemiology, Biostatistics, and Occupational Health. She is a Tier 1 Canada Research Chair and the geosocial determinants of health. The judges will be awarding 4 prizes. Le jury décernera les premières, deuxième et troisième places. First prize in English and first prize in French are each $750 in cash. Il y a un premier prix en anglais et un premier prix en français. Les deux d'une valeur de $750. The English winner will advance to the Canadian Eastern Regionals. La gagnante du prix français avancera à la finale nationale du concours MT180 d'ACFAS. The judges will name a second and third place winner, selecting from all the contestants, English and French. Les gagnants du deuxième et troisième prix seront choisis parmi tous les finalistes en anglais ou en français. The People's Choice Award will be awarded to the audience's chosen favorite, irrespective of the judges' selection. Le prix du public sera décerné aux candidats choisis par le public, sans tenir compte de la sélection du jury. Now the moment we've all been waiting for me to stop talking. The presentations are here. We have a total of 15 presenters today. I will introduce each of the presenters, invite them to turn on their camera and microphone, and they will begin when they're ready. The timer begins once they start speaking. I would like to wish good luck to all of the participants. Bonne chance à tous et à toutes. So here we go. Ida Derish. Ida is a second-year master's student in experimental surgery. While the inherent ability for hearts to regenerate has been widely viewed as science fiction, Ida's love for that very genre has been a driving force behind her research. In 2019, she joined Dr. Cesar's laboratory at the Research Institute for McGill's University Health Center to investigate cardiovascular repair treatments for patients suffering from heart failure. She's looking forward to getting to the heart of the matter by continuing her research on stem cells and heart recognition therapies in her PhD at McGill University. Ida, over to you.
We all know someone who has had a heart attack, and it's a scary, traumatic event. But with the improvement of care, more and more people are able to survive heart attacks. And when this happens to someone we care about, we're just so grateful that they're still with us, that they're still alive, that we often overlook the obvious bad signs that happen after their immediate recovery. The reality, though, is that after a heart attack, your heart is now severely damaged for the rest of your life. That's because a part of the heart tissue dies and it never actually repairs itself. It's like having a puzzle and then losing a piece and it never looks right again. So there goes your main source of everything. I mean, the heart pumping keeps your brain, your muscles, every inch of your skin, every part of us alive. So in cardiac research, finding a therapy to regenerate the heart tissue is the holy grail. I'm Ida Derish, and in my project, I want to beat heart attacks by giving your heart more quality beats. Now, to recap the research that's already been going on, stem cells have the theoretical ability to regenerate any parts of our body. But after injecting stem cells into the heart, we realized that these cells just don't work. The stem cells don't stick to the heart, and they end up flushed out by the body, making them completely useless. But what if we could make these stem cells into our own little pharmaceutical company? What if they could pump something out that could regenerate the heart tissue? Well, I'm here to tell you about the new generation of heart repair therapies that I'm working towards, cell-produced drugs. Now, it's known that cells communicate between each other through the messages in the tiny particles that they produce. And my research actually harnesses the power of those tiny particles for heart repair by passing the obstacles of injecting stem cells. So what's my secret exactly? Well, first, I take the stem cells and I grow them on a dish. However, unlike the traditional way of growing the stem cells on a flat surface, I grow them in a 3D space. That essentially gives me a crude version of a tiny little organ that can produce more and more regeneration-oriented particles. And if there's one thing that I want to send out there, it's that it works. When I take these tiny particles and I add them to heart cells, these heart cells start to grow faster. And after all, more heart cells means more regeneration and a healthier beating heart. By giving a cell-produced drug, we're talking about the potential of repopulating an organ that has been damaged by a heart attack, kind of like building up that puzzle all over again. I now have the data that I need to verify my research in an animal model, and I sincerely hope that this cell-free drugs can become the gold standard therapy for patients worldwide and make each of our heartbeats count. Thank you.
Thank you, Ida. So now we have a pause. The judges have to decide what was the quality of the presentation. Was that the best one you'll hear today? Or will there be even better ones? What do you think for the jury, for the People's Choice Award? How would you rank that presentation? Do you think it was clear? Do you think you understand the science behind it? I know working in graduate studies for a long time, when you're a PhD student, you become so focused in all the small details. It's a shock when you have to explain what you're doing to your family, to friends who've never heard of your subject before. I really applaud Ida for being able to translate such an advanced subject into something that I understand. I am a scientist, however. So what do you think in the audience? Would you rank that number 1, number 10, number 15? You get a chance to vote at the end. I'm hoping that somebody's going to message me when the judges have made their decision. I'll find out. If not, I'll just keep talking and you'll get fed up with me. So how many of you in the audience are doing grad studies? How many of you are looking for pointers on how to present for your PhD thesis defense? These are good strategies. The skills that these competitors have learnt will serve them very well in their futures. Okay, I have the flag for the next person. I'm not allowed to spend too long talking. Now we have Lisanne Desharnais. Lisanne is a second-year master's student in human genetics. She's originally from Ottawa and first became interested in cancer research while completing her undergraduate degrees in the University of Ottawa. This passion led her to pursue a graduate studies at the Rosalind and Morris Goodman Cancer Research Center, where she's studying how diet and obesity influence immune-based therapies in lung cancer. Outside of the lab, Lisanne can be found snowshoeing on Mont Royal or on her quest to find the best falafel in Montreal. Over to you, Lisanne.
If you could choose between these two meals, which one would you pick? Would it be the junk food that definitely hits the spot, or a healthier option filled with veggies and plant-based protein? But remember, you're not just eating for one, but also for the trillions of bacteria that live in your gut. Our intestines are home to an elaborate ecosystem of bacteria and other microorganisms collectively known as the gut microbiota. But what should we be feeding the gut bacteria of someone with cancer, especially if this has the power to determine treatment response or resistance? My name is Lisanne Desharnais, and my research focuses on this important link between bugs and drugs. I study a type of cancer treatment called immunotherapy. Immunotherapy has recently changed the game for late-stage cancer, but only about 1 in 5 patients actually benefits from these drugs. But of those who do benefit, they have certain microbes in their gut. I'm studying how we can use food to create an optimal community of gut bacteria that will specifically enhance the effects of immunotherapy. Now, I use mice in my research, so we formulated special mouse food that mimics what humans would eat. This allows us to study diets like veganism and keto, but also a Mediterranean diet with veggies, whole grains, and olive oil versus a Japanese diet containing fish protein, rice starch, and green tea extract. Once these mice have had their meals, we analyze their feces, which are enriched with bacteria present in the intestines. Over 5 months, I collect hundreds of feces from these mice to identify which food causes beneficial bacteria to flourish and just how fast these changes take place. This is linked to how cancer progresses and how these mice respond to immunotherapy. And get this, we found that immunotherapy drugs are very effective when consuming a diet that leads to obesity. Now, this could mean that the bacteria typically associated with a healthy gut is not necessarily the bacteria needed for immunotherapy to work. Does that change your answer to my original question? I'm not saying one diet is better than the other, but for cancer patients undergoing immunotherapy, changing their diet could mean overcoming treatment resistance. Modifying the food we eat is a rapid, accessible, and cost-effective way to change what bacteria lives in our gut. By doing so, we can maximize the number and diversity of patients who respond to immunotherapy. And that is some food for thought. Thank you.
Thank you, Lizanne. What do you think about this one? My day job is as a professor in parasitology at the McDonald campus. And so I've tried to give presentations where you talk about things living in your gut. It's not always easy. I remember going to a conference in Puerto Rico one time, beautiful place. And the hotel had an information desk. And in the line waiting for the information on the tour to the Arecibo radio telescope, the couple in front were saying, "This hotel is weird. Did you hear what those people were talking about? That was disgusting." So, what have you been feeding your gut bacteria today? Did you even think about it when you were having breakfast? There's more of them than there are of you, that's for sure. One of the advantages of the 3MT competition is that you get a clear presentation from lots of different fields of expertise. We've had medicine, cancer, heart disease. You'll see some other interesting topics coming up. And the next one we have is on food from Suyun Park. So if you'd like to put your video on, microphone at the ready, all set to go. Suyun is a PhD candidate in food science. She studied molecular microbiology from her master's degree in South Korea. She's been fascinated by the hidden microbial world and how it interacts with humans and animals. Her curiosity and desire for the pursuit of knowledge led to her researching the vast and quickly evolving world of the microbiome. Her research interest is in understanding and studying biomolecules capable of treating bacterial infections. Besides the lab, she loves exploring nature and writing code. Over to you, Suyun.
In 1928, Alexander Fleming discovered the first true antibiotic, penicillin. Penicillin has been saving 200 billion lives, and antibiotics have largely increased human life expectancy. However, antibiotic-resistant infections are threatening our lives and are expected to overtake cancer death by 2050. Overusing and misusing antibiotics in agriculture and clinical settings has unnaturally sped up the evolution of bacteria to acquire antimicrobial resistance. Can you believe 70% of current antibiotics are consumed by animals, not by humans? Antibiotic residues and antibiotic-resistant bacteria from agriculture circulate the environment and food chain, eventually come back to humans, causing serious infections. Among food-producing animals, dairy cows are where the majority of prescribed antibiotics go because of bovine mastitis, which is an inflammation of cow udder where dairy cows produce milk. My name is Soyeon Park, and I'm studying bacterial interactions and dynamics with bovine mastitis. My research aims to find alternatives to antibiotics and early diagnostic strategies in the context of good bacteria and bacterial interactions. Microorganisms in and on your body make you resist disease better by fighting against pathogens and educating your immune system. In other words, if you lose these well-balanced microorganisms, when this population gets sick, you become more prone to sickness too. Therefore, microbial composition in cow udder can be an indicator of udder health, and good bacteria can help cows resist mastitis infection. In order to understand microbial changes in cow udder that predisposes cows to infection, I'm studying microbial composition before, during, and after the first mastitis infection. Milk samples were collected bi-weekly from more than 500 cows with or without disease over the entire lactation period. After bacterial DNA extraction from those milk samples, I performed targeted amplicon sequencing to see who is there. I've been analyzing the sequencing data from these milk samples to see microbial composition in different health status and different stages of mastitis infection. And I hope that through this study, I can propose biomarkers and probiotics candidates for early diagnostics and therapeutics, and ultimately prevent bovine mastitis and reduce antibiotics use in dairy farms. Thank you.
Thanks very much, Soyeon. So how's your scoring going? Have you picked a winner yet? What are your criteria for deciding who should get the People's Choice Award? May not be the same as the judges, but keep a record. You will be called upon at the end. Do you have questions for any of the candidates so far? Make sure you send in your queries to the link provided on the YouTube video. And at the end, I will present those questions to the candidates while the judges are making up their final decision. I remember being shocked when I was an undergraduate, being told that DDT, which was an insecticide used in the 50s and 60s, was the most common molecule on the planet. I believe now that's tetracycline, or one of its breakdown products. Okay, next, Emily Savaria. Emily Savaria is an étudiante à la maîtrise en sciences végétales à l'Université de McGill, sous la supervision de Jean-Benoît Charon et de Philippe Seguin. Son projet actuel porte sur la différenciation morphologique et génétique des variétés d'ail du Québec. Il s'agit d'une suite logique à ses études en écologie à l'Université de Sherbrooke et en technologie de laboratoire et biotechnologie au Cégep de Saint-Hyacinthe. Elle est passionnée de plein air, de lecture et de jardinage. Avec ce projet, elle souhaite mieux comprendre l'agriculture d'ici et mieux la valoriser. Emily.
La pandémie a mis en lumière une nouvelle problématique, au Québec comme ailleurs dans le monde. Je parle ici du jardinage. Vous êtes nombreux à avoir fait un jardin l'été passé, tellement que plusieurs producteurs de semences se sont retrouvés en rupture de stock. Or, l'obtention de semences de qualité, adaptées à notre climat et aux caractéristiques bien définies, est essentielle à la bonne gestion des récoltes. Imaginez si on comprenait mal nos variétés de tomates. Et donc, après plusieurs mois d'efforts, vous vous retrouvez avec des petites tomates jaunes au lieu des grosses tomates rouges auxquelles vous vous attendiez. Pas l'idéal pour des sandwichs, ça, non? Eh bien, c'est à peu près ce qui arrive avec l'ail au Québec. Je m'appelle Émilie Savaria et ma maîtrise cherche à différencier et ultimement cataloguer les variétés d'ail du Québec. Parce que l'ail est aussi diversifié dans son goût, son utilisation et son apparence que des tomates. Le problème c'est qu'actuellement, on ne comprend pas tellement ce que l'on fait pousser. Ainsi, la variété d'ail, musique, de votre jardin pourrait être totalement différente de celle de votre voisin. Et votre frère ferait pousser une variété d'apparence identique, mais qui porterait un nom différent. Mon but? Démêler tout ça. J'ai donc travaillé avec 35 variétés d'ail, nommées différemment, qui ont poussé pendant 2 ans à Montréal et au Lac-Saint-Jean, pour un total d'environ 6000 plants, sur lesquels j'ai analysé une quarantaine de traits qui portent sur les parties de la plante présentées dans la photo, soit le feuillage, la fleur d'ail, le bulbe, ses gousses et les bulbilles qui sont présentes dans la fleur d'ail à l'état mature. Comme vous pouvez le voir, l'ail est beaucoup plus diversifié que ce que vous pouvez retrouver à l'épicerie. Mais plusieurs des caractéristiques que j'ai analysées vont avoir varié d'un environnement à l'autre, et certaines variétés ont même présenté 2 apparences complètement différentes sur le même site. On ne peut donc pas se fier uniquement aux caractéristiques morphologiques pour différencier nos variétés d'ail. Or, sans identification claire, il est impossible de promouvoir l'ail québécois pour nos marchands, nos agriculteurs et nos chefs. Et comme l'ail étranger représente jusqu'à 90% du marché, on va rester dépendant d'un ail qui est peu goûteux et qui se conserve mal. La solution? Trouver une identité génétique unique à chacune de nos variétés, puis faire une analyse de goût et de conservation va nous permettre d'utiliser l'ail du Québec à son plein avantage, tant dans votre assiette que sur nos tablettes. Mais n'attendez pas, essayez-le. Il est encore temps de mettre de l'ail du Québec dans votre jardin et en cuisine, passez de l'ail de Chine à l'ail du Québec et vous verrez immédiatement la différence. Et je vous le promets, ça vaut le goût.
Merci, Emily. I must admit, I'm a fan. I love Quebec garlic. My passion is hot chili peppers, to be honest. I have some growing for this year already, but I plan to grow some garlic now. I already had it planted last winter. So how about you in the audience? Do you have garlic planted? Have you tried Quebec garlic? It's a good time to try. I've seen it growing in pots. You don't need a big garden. You can grow it on your balcony. Lots of balconies in Quebec. It's almost time to start planting the garden. In Montreal, we're losing the snow. It's about 10 degrees. So pretty soon we should be out there. Hopefully we can all get a vaccine soon and be out enjoying ourselves. Okay, we're ready for the next one. Diana Diorio. Diana is a first-year master's student in experimental medicine. She's always had a passion for cardiovascular health and vascular biology. And in university, she became very interested in women's health. Diana decided to pursue her interest in women's health and vascular biology in the form of an internship with the vascular health units of the RIMUHC, examining sex disparities in stroke and artery blockages. She's been working at the vascular health unit since and is excited to share her project with you today. Over to you.
Every 9 minutes, a Canadian suffers a stroke. In 2013, my grandfather was one of them. We were told that a fat-filled blockage in the artery of his neck ruptured. These fatty blockages are called plaques and are the main cause of stroke. Luckily, my grandfather survived, but had he been a woman, had it been my grandmother, she may not have been so lucky. Women have higher mortality and higher disability rates post-stroke compared to men, with 1/3 more women than men dying of stroke each year. Think about that. Women are disproportionately affected by stroke, and my research is to find out why. My name is Diana, and I study how sex hormones affect plaque development. In doing so, I hope to decrease the incidence and burden of stroke for both men and women worldwide. Our lab has been collecting plaque specimens since 2009 and has amassed over 600 samples. In dissecting these samples, we have found that plaques isolated from women look very different than those isolated from men on the cellular level. This means that there may be sex-specific differences in the plaque tissue itself that explain the disparities we see in stroke outcome. And I think that sex hormones, specifically estrogen, may be the reason why. You see, estrogen exerts beneficial effects on the blood vessels and protects women from cardiovascular disease basically until menopause. However, after menopause, estrogen can harm the arteries. In my research, I take plaques from men and women and compare their morphology and composition. I quantify the estrogen in the plaque, I study its activity, and characterize whether estrogen promotes plaque development. And so far, I have found something quite interesting. Estrogen is not only present within the plaque, but is also associated with severe plaques. This suggests that estrogen may exacerbate severe plaque development and may explain why women have worse stroke outcomes. Current guidelines see stroke in men and women as the same, but what if they are different? Determining how sex hormones affect plaque development is extremely important. It can allow us to better predict women at risk for severe stroke and can lead to sex-specific therapies that decrease the incidence of stroke in both men and women worldwide. And for that, my grandfather would be proud. Thank you.
Thank you, Deanna. Very good. So we've had a series of biology presentations so far. We'll be going on to engineering next. So a slight shift. But it's interesting to see that when you're a PhD student and you are focusing so hard on the small details of your project, the ultimate goal can be life-changing for people. You can have a real impact in the world. And sometimes it's important to lift your head away from the bench to actually take a look around, speak to the people around you to see how to engage with the people that you're doing the research for. So this is where the 3MT competition comes in. Do you think they're doing a good job? Do you think their research is life-changing for the population as a whole? Next, we go on to engineering. And we have Sikander Sajid. Sikander is a final year PhD student in civil engineering. While growing up, he developed a passion for solving sustainability and safety-related issues of the built infrastructure through applied sciences. He studied undergrad in Pakistan and in the US as a Fulbright exchange student. His doctoral research mainly focuses on modifying non-destructive tests for optimal health assessment of infrastructure components, strength estimation of construction materials with NDT, and developing probabilistic framework for quality control, incorporating the intrinsic uncertainties associated with NDT methods. Over to you, Sikander.
I cannot start my camera.
I don't know if we have technical support that can help with that.
Yeah. Okay, thank you. How many of you have been in an earthquake? Let me share my experience with you. On a serene morning in the fall of 2005, I was a high school student sitting in math class in the northwest of Pakistan. Suddenly, there were intense jolts of earthquake. Fortunately, I was safe because our building survived. However, the majority of the buildings in the city did not, which killed more than 80,000 people in this earthquake. It was shocking to know that 17,000 of them were only the school children. Following the earthquake, the low quality bricks, concrete bricks, apparently because of the absence of any efficiently quality control systems in its production has been identified as the main cause of the failure of the small buildings. In an earthquake with a building having weak concrete bricks, what happens is that in each vibration, it will be unable to come back to its original position, leading to a progressive but quick failure, which is what you can see on the slide on the left of the slide. I'm Sikandar, and as part of my PhD, I developed a technology which could be used for the quality control of concrete bricks in the production plants. The concrete brick has to be broken in order to know if it is strong enough to meet the standard requirements. However, my approach is non-destructive. I'm simply using stress waves generated by a hammer tap in the concrete brick and record the resulting vibration. I found that the frequency of the vibration in the concrete brick has a strong correlation with its strength. I also found that you can reliably use this correlation developed in the lab to estimate the strength of concrete bricks in the production plants. Okay, I have a test which works very well. It's non-destructive. But when I go to a factory, there are thousands of bricks. It's impractical to test each one of them. This is where I introduce a probability framework that tells me how many bricks should I select in order to have a representative batch and give me results with a certain percentage of surety. The technology is cheap, the process is fast, and it works. Our efforts are channeled toward its implementation. I'm cautiously optimistic that with all these efforts will lead to have resilient houses and schools, which is important because earthquakes do not kill people, buildings do. Thank you very much.
Thank you very much, Sikandar. What an important topic. Anytime that you have an earthquake, it can cause a lot of devastation like this. You can see Sikandar's point. If you test concrete by breaking it, then you don't have the concrete to use. What do you think for the People's Choice Award? How is the presentation style? What about the quality of the way the presentation was made? Are you keeping notes on all the presentations so far? Would you go back to your own university department and recommend that these competitors get invited to give you a seminar? I'm sure they can give a much more detailed version in 3 minutes. Okay, so we go on to the next one. Anirban Kundu hails from the city of Kolkata, India. He's a PhD candidate in environmental engineering and in Professor Sarvesh Gosai's group at McGill. He holds an undergraduate degree in biotechnology from NIT Dhargapur and master's in biochemical engineering from IIT Delhi, both in India. His academic career has spanned diverse research projects in bioengineering. Presently, he's working with microbes and nanomaterials to enhance cleanup of oil spills. Anirban has already represented India in the international forum through an entrepreneurial activities. Apart from research, he holds a number of leadership roles in alumni associations, student mentorship programs, and startup ventures. Over to you, Anirban.
Exxon Valdez, Alaska, Deepwater Horizon, Mexico, Lac Mégantic, Quebec. Are you lost? Let me help you. These are some of the major oil spills that have happened in the last 10 years. Canada has more than 250 such oil contaminated sites, a majority of which are located in North Canada, an area that is cold, that lacks inhabitants, and where there is zero access to infrastructure and facilities. What if I told you that right now, as we speak in this 3MT, there is evidence of active oil contamination in the Arctic? So how do we solve this problem? Well, the good thing is nature, thankfully, has provided us a solution. In this case, bacteria that love to eat these oils. But here's the problem. If you consider the North and its soils, there are so many different physical and biological characteristics that unless you attempt to link these two, it is very difficult to arrive at a comprehensive solution. And that is where my research comes in. Hi, everyone. My name is Anirban, and today I will tell you how I attempt to link the physical and biological attributes of oil-contaminated soils. My soils come from a number of locations in North Canada, as you can see in the map. In the lab, I artificially contaminate them with Arctic diesel, thereby simulating the oil spill as it happens there in the site. Then I conduct experiments at Arctic relevant temperatures in special environmental incubators. Over time, I do two types of analysis. Number one, bacterial analysis. How are the various oil-degrading bacteria responding in the different soils? Who loves to grow versus who doesn't? Active versus inactive species? Biological analysis. On the side, physical analysis. I individually isolate soil aggregates and I shower them with X-rays and nitrogen gas at very low temperature to get you a three-dimensional microstructure of these aggregates, what you see on the right. Why? Because these are the homes, the microhabitats where these bacteria live. Physical analysis. Linking these two. My research, understanding these submicron level properties for a number of different soils will tell you what is the expected level of cleanup I can achieve for spills happening right now in the Canadian Arctic. I am confident that my research will help Canada in achieving security, sustainability, and resilience in environment, both today and tomorrow. Thank you.
Thank you, Anirban. Very interesting. Did you know that the coal beds and oil fields that we depend on were deposited by organic material that didn't decompose properly? One of the reasons that trees don't decompose properly hundreds of millions of years ago is that the enzymes required to break down lignin had not evolved yet. Now we're applying those same tools to try to find ways to break down oil that's released into the environment. Good work. So what do you think? I'm guessing we're close to halfway through so far. Have you set your standard for what is a good presentation? Moving on to the next, another engineering student, PhD student, Natasha Jacobson. For the past 3 years, Natasha has been pursuing her PhD in mechanical engineering. Prior to graduate school, Natasha completed her BSc at the University of Manitoba, where she was first introduced to the biomedical research area. Biomedical engineering has combined the technical aspects of engineering with healthcare, a union of particular interest to Natasha. As such, her present work looks to design medical devices to improve the treatment and diagnosis of future patients. Over to you, Natasha.
Have you ever laughed so hard you peed your pants? Okay, now imagine that same bladder leakage every time you pick something up. Every time you get out of bed. Every time you sneeze. This is the daily reality for 1 in 10 Canadians who suffer from incontinence sometime in their lives. Incontinence is the lack of bladder control, and it's caused by raised intra-abdominal pressure, and this is the basis for my own research. Now, intra-abdominal pressure is the pressure contained in the abdominal compartment. Pressures in this vessel can increase when you breathe in, you feel your belly expand, or when you activate your abdominal wall muscles. And that can be by any of the activities I mentioned previously. Laughing, sneezing, exercising. Pressures that are too high, however, can cause that leakage that is completely out of our control. Currently, physical therapists offer suggestions for therapies to prevent this leakage, but aren't actually able to quantify patient improvement. This problem is perpetuated by undesirable measurement methods in intra-abdominal pressure. In fact, the current recommended means of measurement is literally via the bladder. That is, tubes are inserted into your bladder where a known volume of fluid is injected and the resulting pressure is measured. It's unlikely you or I would go lining up for this particular procedure. However, through my PhD, I have patented a non-invasive alternative to traditional pressure measurement. This novel technology induces a gentle suction against your skin from which the resulting tissue movement, denoted by W, is measured. With these two values, the applied suction or pressure and W, we are able to directly calculate a patient's underlying physiological pressure. This new technology provides the millions of Canadians currently suffering from incontinence a means of better guiding their physical therapies to prevent that future leakage. Perhaps we can all laugh a little more easily knowing the cause of possible accidents. Thank you.
Thank you, Natasha. So far, we've had a mix of PhD and master's level students. And you may be wondering, what is the difference between master's and PhD level studies? Both are required to understand their subject area, to be able to conduct research in that subject area, to analyze the results, produce conclusions, and most importantly for today, to be able to communicate those results effectively. Master's students typically take 1 year to 2 years. PhD, typically 4 or 5, hopefully not too many, 6 years. That's a long time to dedicate your life. And at the beginning of a graduate degree, you can be intimidated by how long it will take you to get to the end. While you're doing a graduate degree, you cannot imagine doing anything else. After you finish doing a graduate degree, you think, that was fast. Okay, on to the next one. Another PhD student. Natalie Droidini. Natalie is a second-year PhD student in the biology department in Redpath Museum. Growing up, she aspired to become a doctor of veterinary medicine, but the field of ecology and evolution captivated her upon starting university. She had worked on diverse projects, including animal-borne disease spread, biological control techniques, conservation and monitoring of endangered animal populations, species assemblages and movements, as well as science communication and public outreach. She is also interested in the link between ecological research and science policy, for which she completed an environmental affairs internship with the United Nations. Over to you, Natalie.
I'm going to give you 3 hints, and you have to try to guess what animal I'm referring to. Ready? 1, as a baby, it keeps our waters clean by eating algae that's otherwise toxic. 2, as an adult, it has a crucial role in pest control because it feeds on insects. And finally, it's referred to as a bioindicator because it's so susceptible to environmental changes that it can give scientists a heads up before we can detect the change. Have you guessed what my animal is? It's a toad. My name is Natalie Droidini, and I combine mathematics with ecological data on small-scale toad movements to answer a large-scale question. What drives animals to leave their habitats? Ecologists have monitored animal populations with the use of tracking devices to figure out how animals utilize the space around them. But why I care about their movements out of their habitats, I'll tell you at the end of this talk. Now, we know that animals are moving towards the poles and deeper in our oceans in response to climate change. But that's not the only factor at play. There have been attempts to unravel these other factors, but the results remain inconclusive. That's because it's just too difficult and expensive to track a large number of animals for extensive periods of time, except when using toads. We are able to track thousands of individual toads without the need for any invasive tracking device. All we use are their photographs. The patterns on the toads' backs act as ID fingerprints, and location timestamps allow us to plot their trajectories. And although they move over seemingly short distances, those distances in relation to their body size were scaled with a little bit of mathematics to mimic the patterns of larger animals in various landscapes. With this data set, along with environmental variables, I was able to revisit those inconclusive theories and start building a model that can explain the movement patterns of several species. Now, if you're still wondering why one would explore animal movements, here's why. When a species leaves its habitat, that leads to a disruption of that ecosystem's composition. And that disruption in turn impacts us. So by figuring out why they're leaving, we can better predict shifts in our food sources, the spread of animal-borne diseases, and even come up with better conservation attempts. Now you know that even small-scale toad movements can have large-scale implications. Thank you.
Thank you, Natalie. Interesting work indeed. How's your scoring going? Have you picked a winner yet? We still have quite a few presentations to go, so you'll have to hold on to a few top spots. Has your evaluation changed as you've heard the presentations? Did you start out with expectations of what to hear, and have those expectations changed? I think mine have. I won't try to influence anybody by saying what I think. I won't be voting on the winner. I'm just the presenter. But I've already heard some amazing talks. So what do we have coming up? Well, we have some more particle physics next. We have more engineering. We have more health science. And next up, we have Oriane Canes. Oriane est doctorante en physique des particules. Elle a effectué ses études de bac et de master en physique en Belgique à Louvain-la-Neuve. En 2017, elle a rejoint le groupe Atlas du département de physique de McGill pour travailler sur l'analyse de collision de protons de LHC. Elle s'est également investie dans le projet de vulgarisation de son département ainsi que dans la vie étudiante, étant que président de l'association étudiante d'études supérieures en physique de McGill. Maintenant, basée au CERN, en Suisse, elle travaille à la construction d'un nouveau morceau de détecteur Atlas. Bienvenue, Nathalie. Oriane, désolé.
Si vous prenez 2 pommes et que vous les faites entrer en collision, que va-t-il se passer? Pas grand-chose, vous aurez des pommes abîmées. Mais si on répète cette expérience dans mon laboratoire, il se passe quelque chose de complètement différent. On a un gigantesque accélérateur qui nous permet de lancer nos pommes à des vitesses proches de celles de la lumière. Et quand elles entrent en collision, toutes sortes d'autres fruits sont produits, des bananes, des kiwis, etc. Moi, dans tout ça, je dois retrouver 2 raisins et un melon. Bon, je dis pommes, mais ce n'est pas tout à fait exact. On accélère et on collisionne des particules subatomiques appelées protons. Moi, je cherche à observer la production de 3 particules élémentaires, 2 photons et un boson W. Il est très peu probable de produire ces particules simultanément, et ce processus n'a encore jamais été observé. Mais d'ailleurs, comment observe-t-on ces particules? Eh bien, elles sont si petites qu'on ne peut pas les voir au microscope. Il nous faut donc d'autres types de détecteurs. D'ailleurs, on ne peut pas vraiment les voir, mais seulement mesurer certaines de leurs propriétés. Mon détecteur, Atlas, mesure 40 mètres de long sur 20 mètres de diamètre, et il est composé de différents modules. Dans les couches internes, on mesure la trajectoire des particules pour en déduire leur charge électrique. Dans les couches suivantes, on mesure l'énergie des particules en les arrêtant. Imaginez qu'on lance une orange contre un mur, on peut mesurer son énergie grâce à la taille de l'impact laissé sur le mur. Avec ces informations, je peux reconnaître les particules créées et sélectionner les collisions qui ont sûrement produit mes 2 photons et mon boson W. C'est bien beau tout ça, mais à quoi ça sert? À rien. Moi, je suis juste extrêmement curieuse et je veux comprendre comment fonctionne l'univers. On connaît très bien les lois physiques qui dirigent nos collisions, mais notre théorie est malheureusement incomplète. Par exemple, on ne sait toujours pas de quoi est faite la matière noire. On ne sait pas non plus pourquoi il reste si peu d'antimatière dans l'univers. Pour espérer répondre à ces questions et à bien d'autres encore, il nous faut étendre notre théorie, le modèle standard. Mon observation permet de mesurer un paramètre fondamental du modèle standard. Cela nous aidera à mieux comprendre comment y inclure la description de nouveaux phénomènes. Tout comme nous avons une théorie unique pour décrire la chute des pommes et le mouvement des planètes, j'espère qu'un jour, nous aurons une théorie unique pour décrire toute la matière et ses interactions. Merci.
Merci, Oriane. You may wonder why you keep having to listen to me between the presentations. It's not because I like the sound of my own voice. The judges have an incredibly hard decision to make, and they don't have much time. So between each talk, I've been a judge in the past, so I know what they have to do. They have to fill out all the different criteria for each candidate, and then give them scores that they can use at the end to rank all the people. It's difficult to remember how good the first one was when you're listening to the 15th presentation. So far, we've had 10. We have 5 more to go. So we're quite a way through. And at this point, the judges have quite a stack of paper to look back on. So it takes them time to actually decide how to evaluate each candidate, and how do you compare a presentation on particle physics with one on heart disease and stroke? Not an easy task. I'm glad I'm the compere this time and not one of the judges. I don't envy their task. So next, we have another switch. We've had biology, we've had physics, and now educational and counseling psychology. So Deanne McDonald is a 5th-year PhD candidate in the Department of Educational and Counseling Psychology. Prior to returning to graduate school, she worked as a speech-language pathologist, focusing on children with autism and reading disorders. She was amazed by preschool children with autism who could read as young as 2 years old. These children inspired her research to find out more about this wonderful ability and learn how to focus on the strengths of people with special needs as a means to helping them with their challenges. Over to you, Deanne.
I want to start by asking you to read these words aloud. Brabium, umbel, snood. I'm sure you can all read these words, but I expect most of you don't understand what they mean. You've just experienced hyperlexia because you were able to read these words, but you didn't understand their meaning. Preschoolers with autism and hyperlexia can read words at a grade 2 level when they're only 3 years old, but they don't understand the meaning of the words either. And while hyperlexia is classified as a reading comprehension disorder, I see it as a strength in advanced word reading abilities. My name is Diane McDonald, and my research focuses on strength-based interventions that target a child's strength to improve an area that's challenging for them. Currently, there are no programs to close that gap between advanced word reading and poor reading comprehension for preschoolers with autism and hyperlexia. So I designed a tablet-based reading comprehension intervention for preschoolers 3 to 5 years old with autism and hyperlexia to improve their reading comprehension, starting at the most basic level, word to picture matching. As an example, the child would match brabium to prize, umbel to flower, snood to hairnet, using easier words, of course. The child first learns listening comprehension by simultaneously hearing and reading the word and then matching to picture, and then learns reading comprehension by just reading the word and matching to picture, and then advances to phrase and sentence picture matching. I asked parents to support their child's use of this tablet-based intervention at home over a 6-week period, and I assessed the child's listening and reading comprehension at 3 different time points. I found that at the end of the 6-week intervention period, the children with autism and hyperlexia had significantly improved their reading comprehension compared to a prior 6-week no intervention period and compared to 2 control groups, a typically developing group and a group with autism without hyperlexia. What was really surprising was that I also found that all the groups improved their listening comprehension skills. So the benefits actually extended beyond the target group. These improvements in listening and reading comprehension hold the potential to positively impact the development of communication, social, and academic challenges faced by children with autism. The next steps will be to make this intervention available online so more kids can benefit from it. In the short term, though, I hope that the next time you look at a child with or without special needs, that you try and see their strengths over their deficits. Because as I showed, that might just hold the key to supporting their growth, and it might help their friends and classmates too. Thank you.
Thank you, Deanne. Very interesting. When I was young, my mother was a primary school teacher, teaching mostly 4-year-old, 5-year-old children. And I remember that she had such a passion for teaching reading that she would do homeschooling of adults who hadn't learned to read ever in their lives. So these are adults who are in their 30s who hadn't read a word. And it's amazing to see the difference that this kind of understanding can have on people. Suddenly to realize that there is an entire universe of communication out there that you simply were not aware existed, that you could share ideas with written words on a page. And it's amazing to think that children with autism may be able to do things in a different way that some people might say was better than people without autism. We quite often think of people with special needs as requiring our help, when sometimes they may actually be a step up. Dentistry, that's where we're going next. Shiman Gao is a PhD candidate in the Faculty of Dentistry. Before joining McGill, Shiman obtained her Bachelor's of Dental Surgery and Master of Oral Maxillofacial Surgery in China. During her training in China, she spent more than 500 hours teaching English and math in the rural areas. As a responsible dentist, she carefully brushes her cat's teeth with an interdental brush every day. As a researcher, Shiman believes that a great research project can help more people than treating patients in the clinic. She's excited to share her passion for research and 4 years of work with everyone. Over to you, Shiman.
Thank you, Robin. One day, you have to go to your dentist to have your wisdom teeth removed or just to get a filling. Dentists always have to use a long and sharp needle to insert some anesthetics to freeze your filling before any treatment procedure. What would you feel? The fear of needle happens in 10 to 20% of our population, can lead to avoidance behavior. And eventually, avoiding necessary dental treatment just make their problem worse with a higher treatment cost in the future. A needle-free device can solve this problem. How it works? It works by creating a liquid jet, just like the car washer you use to wash your car, that liquid jet, but with a much higher injection speed and much thinner diameter. This way, the liquid jet can go through our skin without a needle. It sounds so cool, right? The needle-free device has the potential to overcome all the limitations related to needles. But how come you never seen such a device in any dental clinic? That is because it's not ready yet. There's still a big knowledge gap between the research and the clinical practice. And because of this knowledge gap, previous clinical trials showed controversial results. Hi, my name is Qiman Gao. I spent 4 years to solve this problem. Our team solved this problem in 3 steps. Step 1, understanding the mechanism of needle-free injection. On materials similar to human soft tissue, we did thousands of injections with the needle-free system to study how different factors can change the outcome of needle-free injection. And we got a predictive model. Step 2, developing an optimal technique for needle-free injection. On more than 20 cadavers, we tested the needle-free anesthesia. And using the predictive model we got previously, try to find the optimal parameter. The results showed that the needle-free anesthesia using our optimal parameter is totally feasible on cadaver and as effective as needle injection. Step 3, validating this technique in clinical practice. We conducted a randomized controlled clinical trial. The results showed that the optimal needle-free anesthesia is as safe as needle, and its clinical success rate and clinical efficacy is as good as needle. To conclude, I hope you feel the excitement that I feel. We are working hard to create a needle-free dental clinic that gives you a better anesthesia experience. Ultimately, your cousin who might be afraid of needle or pain can stop avoiding necessary treatment. Thank you.
Thank you, Shiman. Well, I can certainly relate to this one. I'm not afraid of needles myself because when I was 29, I became a type 1 diabetic. I have to use a needle twice a day. If I can find a needle that doesn't stick me, that would be fantastic. My mother was terrified of needles. Every time she went to the dentist, she had an arrangement with the dentist. The dentist would put the syringe in his hand and hide it and say, oh, I'm not going to inject you. I'm just going to take a quick look and, oh, it's too late. You've had the injection now. And if he didn't do that, my mother would be out of the dentist chair and running down the hallway. So this has a big impact on a lot of people. When was the last time you went to the dentist? I'm going on Monday. Hopefully no freezing, it's just a dental checkup. But I'm sure that we can all relate to the fact that when you're sitting in that chair, you know what's coming. Okay, I think we're ready for the next. Back to engineering, mechanical engineering. Trevor Carter is a third-year graduate student in mechanical engineering. He's always had a passion for tinkering and designing, whether that's outside in the garage or in the lab. This compounded with an interest in translational research brought him to Montreal to study at McGill University. His focus is on developing a physics-driven surgical simulator for training spine surgeons. He hopes to use his education and communication skills to bridge gaps among interdisciplinary teams and from these teams to the general public. Over to you, Trevor.
Imagine you're in a plane coming into land. You're just a few meters off the ground and the plane is shaking all over the place. In these last few moments, do you want this to be the pilot's first time landing or their 100th? I think it's safe to assume we'd all choose the 100th. And pilots train in simulators, like you see on the left, to get through these first few landings. They need to pass tests every year in a simulator to fly with passengers. So why don't we expect the same for our surgeons? The answer is that much of the technology for this is just now ready. Modern robotics and computers have finally advanced to the point where we can make the simulators that surgeons need. My goal is to make sure that when a surgeon does their first procedure on you, your grandparent, or anyone else, that they've already practiced hundreds of times. My focus is in haptics, which is the sense of touch. And while they use all of their senses, where surgeons really stand out from you and me is with their hands. When you think of a pilot pulling up on a yoke, a robot can provide this type of feedback fairly easily. However, in surgery, the feedback is much more complex. They're finer and smaller movements. And in spine surgery, only a couple millimeters is the difference between hitting a muscle or your spinal cord. I test tissues so that I can understand the biomechanics that surgeons feel during a procedure, especially in the delicate areas of the spine. I then use this data to build mathematical models to mimic the tissue. Surgeons' hands are so sensitive that I've had to come up with ways to update these models and our robot 1,000 times per second to provide accurate training. I've even built an entirely new robot to add to ours to help it feel like a real procedure. Now that we've done this, the muscle feels like muscle. And if the surgeon digs a little bit deeper and hits the bone, it now feels like bone. We can now use this data acquired from just a couple cadavers to train hundreds of surgeons. Now that we've built it, we're bringing it to surgeons to help them evaluate and help us improve it. We can now differentiate between expert and novice surgeons. Giving feedback will allow us to make new surgeons become experts before they even touch a real person. Just like a pilot with hundreds of landings, only practice can make a surgeon an expert. The steep and very risky learning curve for these first few landings or surgeries are where my research can help. And I think we can all agree that we'd like as many surgeons as possible to be the experts before we or someone we love meets them in the operating room. Thank you.
Thank you, Trevor. Have you been timing these? These candidates have 3 minutes, not 1 second more. They are facing a clock. When it was in person, it was a timer sitting on a table. Now they're well aware when they're talking that the seconds are ticking away. Do you see them being nervous about that? I haven't seen any of that. The training so far has been really good. So we have a couple more presentations. And after that, we'll move into a question and answer period. So if you have any questions for the candidates, don't forget to send your questions in. And I will be asking those to the candidates while the judges are making their final decisions. I certainly don't envy them that task. But there's so many diverse, different talks that we've heard so far. What are your questions going to be like? So now we move on to kinesiology sciences and Bradley Crocker. Brad, is that the right one? Nope, I missed one. Apologies. Katie Diane. Katie est une étudiante de première année en doctorat étudiant de sciences quantitatives du vivant. Après avoir fait un bac en physiologie et mathématiques, elle a combiné sa passion pour les mathématiques et l'électrophysiologie cardiaque au cours de sa maîtrise en physiologie, également à McGill. Au cours de ce programme, elle a développé des modèles mathématiques arythmiques cardiaques qui ont aidé à résoudre des questions importantes sur le sujet. À présent, alors qu'elle entame son doctorat, elle a hâte de développer davantage de ces modèles mathématiques en conjonction avec des modèles expérimentaux d'arythmie cardiaque.
Bonjour, je vais vous demander de prendre quelques instants. Fermez vos yeux et imaginez-vous ceci. Vous êtes de retour à vos premières années de secondaire. La cloche vient de sonner. C'est enfin l'heure du déjeuner. Vous entrez dans la cafétéria et vos yeux se posent directement sur la personne qui vous plaît. En un instant, votre cœur s'emballe. Vous avez l'impression qu'il va vous sauter de la poitrine. Ce sentiment où votre cœur bat la chamade, C'est ce qu'on appelle une palpitation cardiaque. Vous pouvez maintenant ouvrir vos yeux. Il y a de fortes chances que tout le monde ici ait déjà ressenti ce type de palpitation durant de fortes émotions ou lorsque vous avez bu un peu trop de café ou de Red Bull. Mais ne vous en faites pas, ce n'est rien de grave. En théorie, si vous remarquez toutefois que ces palpitations sont fréquentes pour vous et occurrent sans préalable, il est possible que vous ayez une condition cardiaque appelée parasystolie, provoquant ces palpitations récurrentes. Imaginez que mon poing représente un cœur. En temps normal, la contraction est initiée par le nœud sinusal dans l'oreille droite. Or, chez les patients atteints de parasystolie, il y a un deuxième foyer d'activation, un foyer ectopique dans les ventricules, et lorsqu'il s'active, il cause de larges contractions, telles celles encerclées en rouge sur la diapositive. En n'utilisant qu'un électrocardiogramme comme celui-ci, les médecins peuvent avoir de la difficulté à différencier entre les extrasystoles naturelles, dues à de fortes émotions, et celles issues de parasystolie. Voilà où ma recherche entre en jeu. Je m'appelle Hadi Diagne et j'étudie la parasystolie en développant des modèles mathématiques afin de pouvoir reconnaître ces rythmes chez les patients. Contrairement au modèle de parasystolie précédent, où l'interaction entre ces deux stimulateurs est simulée sans tenir compte entre de l'espace physique et de la distance qui les sépare, mes modèles mettent l'emphase sur l'importance et les conséquences de la distance entre le nœud sinusal et le foyer ectopique. Dans mes modèles, je vise à simuler et à prédire l'allure des électrocardiogrammes de rythme parasystolique. Ainsi, en comparant mes électrocardiogrammes simulés à ceux de patients ayant un diagnostic de parasystolie, nous avons pu confirmer la présence d'un foyer ectopique qui s'active indépendamment du foyer naturel. Le but de ma thèse est de construire des algorithmes d'apprentissage automatique qui aideront les médecins à diagnostiquer la parasystolie. De plus, le modèle pourra servir à prédire les circonstances dans lesquelles l'activation ectopique conduirait à des arythmies plus graves. Ainsi, à l'aide de ces nouvelles technologies, les médecins sauront plus facilement différencier entre l'arythmie et un simple coup de cœur. Merci. Thank you.
Merci, Katie. Apologies to Bradley for giving a heart attack, thinking he was coming on next, but he will be coming on next now. So we have the final talk coming up, after which we'll open the voting for the People's Choice Award. You can find the link on the description of the YouTube channel. So make sure to click that link and vote for your winner. Who's going to win? Who do you think the judges are going to overlook? Do you have a certain person that you feel really grabbed your attention, was charismatic, really made a dent in your day? After the question period, after the voting period, we'll have a question period followed by the announce of the voting. So here we go with the final talk. This time it really is Bradley Crocker. Brad is a second-year PhD student and a lecturer in the Department of Kinesiology and Physical Education. Through his undergrad studies in kinesiology at the University of Calgary, Brad developed an interest in how people inform themselves of their healthy behavior. This led him to conduct research with his current supervisor, Dr. Lindsay Duncan, with a focus on health psychology and information-seeking behavior. When not in the lab, Brad can be found at the pool coaching the McGill women's and men's varsity swim teams. Over to you, Bradley.
Thanks, Robin. When you feel sick, get a nagging pain, or notice some other irregularity in your body, where do you go to find out what's wrong? If you're like the majority of Canadians, the first place you turn to for advice is the internet. I'm Brad Crocker, a PhD student here at McGill, and I study how people search for health information online. While the internet can be a great place for public health advocates to share information, it can also be a minefield of inaccurate and misleading content. We've seen this during the ongoing pandemic, where misinformation surrounding COVID-19 spread widely. Other examples include unproven diet supplements, bogus wellness techniques like detox cleanses, and anti-vaccine messaging. Vaccines are a miraculous technology that prevent millions of deaths each year, but they become useless when a misinformed public won't take them. This is why the World Health Organization lists vaccine hesitancy amongst the top 10 threats to global health. Misinformation undermines trust in doctors, can promote panic and dangerous behavior, and ultimately diminishes the health and wellness of our communities. So what can we do about it? Well, due to the vastness of the internet and the speed at which content is shared, eliminating misinformation online is nearly impossible. So we must empower citizens to identify high quality health information online for themselves, or in other words, improve what's called their e-health literacy. The most widely used tool to assess e-health literacy right now is a self-report questionnaire to gauge how confident you are you can find good health info online. It's simple to administer, but it comes with some big limitations. Like, people often overestimate their abilities, especially when it comes to judging the accuracy of content online. As well, people aren't always consciously aware of their browsing behavior. I'm sure many of you have at some point done yourself down a rabbit hole of clicking related posts and web pages. Thinking back, do you think you could accurately recall exactly what attracted you to each click? To reduce these limitations, my research uses eye tracking. Eye tracking involves a small infrared camera directed into users' eyes to tell us where they're focusing on the screen. We use this while recording their monitor to see exactly what people look at as they search the internet to find health information. After browsing, we interview participants while they watch a replay of their own eye tracking data to help us understand their thought processes at each step. This allows us to analyze things like how they select from a search results page, how they determine if a website is trustworthy, and how they verify or don't verify the information they find with other sources. From this research, we're working to find behaviors that consistently differ between those with high and low e-health literacy. This will help us to create a new test based on practical skill instead of just self-confidence. This can also help us create teaching methods to help people evaluate information online so that their next health choice is based on facts and not falsehood. Our greatest weapon against misinformation is a society that would never believe it. Thank you.
Thank you, Brad. Very relevant in the current times. So that was our final presenter. Now the judges have the worst possible time of going and deciding who's the winner. We also open up the People's Choice Award. There's a link. So there's a link in the video description. So make sure that you go to vote. Who should you vote for? A quick recap. Ida Derish, Cell-Free Therapies Solving the Puzzle of Heart Repair. Lisanne Dehaene, Feeding the Gut to Fight Cancer. So-Yoon Park, The Good Bacteria to Prevent Infections. Emily Savaria, Savez-vous planter de l'ail? À la mode du Québec. Diana Diorio, Stroke. What does biological sex have to do with it? Sikandar Sajid, NDT-based quality control of construction materials for resilient buildings. Anirban Kundu, bacteria cleaning up oil spills in the subarctic. Natasha Jacobson, blame pressure for bladder leakage. Natalie Gerardini, using small-scale animal movements to answer a large-scale question. Oriane Canes, observation d'un boson W et de deux photons produits dans la collision de protons. Diane McDonald, strengths over deficits. Shiman Gao, a needle-free dental clinic. Trevor Cotta, spinal surgery, easy as landing a plane. Katie Jian, modèle mathématique de parasitolie. Brad Crocker, navigating health misinformation, assessing proficiency online, information seeking. So, cast your votes now. Vous pouvez voter pour le prix du public via le lien présenté dans la description sous la vidéo. I think you will have 10, 15 minutes to vote. Make sure to get your vote in early. Make sure you submit your questions too for the presenters. So coming up next, we'll be asking questions to the presenters. So opening with the questions to the presenters. So this is a question for all the presenters or anyone who wants to jump in. What was your main takeaway from the process of putting your research into 3 minutes? It's not a long time. Who wants to take that one? Any of today's presenters?
I guess I can go really quickly.
I see Ida, yeah.
Yeah, hi. So I think the main takeaway is that, as a scientist and as a, student, you can, if you're passionate about what you're doing, you can go on and on and on about it for, an hour, 3 hours sometimes. And the thing is, what was really interesting for me is like cutting away all the superfluous stuff and kind of synthesizing it into something that, my grandma can understand, which is something I actually haven't been successful in until now. So I'm hoping that I can go home and she'll finally be like, I understand the research that you do. So fingers crossed.
Have a question for Soyun. How do you determine the quality of milk as a result of treatments? How effective is the good bacteria compared to antibiotics?
Oh, sorry, could you repeat the question again?
Sure. How do you determine the quality of milk as a result of treatments? How effective is the good bacteria compared to antibiotics?
In terms of determining healthy milk, good milk, there is a techniques that you can actually determine the quality of milk. So we measure cow immune cell in the milk sample. So if you don't have high immune cell in cow milk sample, that means your milk samples are really good. But if you have bacterial infection in your milk sample, that means the more cow immune cells will come. So you will measure more somatic cell count, which is cow immune cells. In terms of comparing antibiotics, there are some field trials using probiotics to test the efficiency of these kind of probiotics to prevent mastitis infection comparing to antibiotics. The result turns out it kind of compatible. It's not a 100% perfectly prevent mastitis, but it's compatible to the efficiency of antibiotics.
Thank you. That was very good. Une question pour Emily. Vous mentionnez la morphologie variée de l'ail dans votre présentation. Pouvez-vous élaborer ce qu'est la morphologie et son importance aux yeux des cultivateurs?
Dans le fond, la morphologie, c'est vraiment l'apparence de l'ail. Donc, pour les cultivateurs, là, ça va être le nombre de cailleux, principalement là, de gousses dans ton bulbe qui va déterminer à quel point ils peuvent replanter leur stock d'ail ou pas, puis quelle portion de leur stock ils vont pouvoir garder pour l'année prochaine. Mais sinon, pour le producteur, l'apparence, à part la grosseur, n'a pas vraiment d'impact. C'est souvent au niveau du consommateur que ça va changer. Les consommateurs vont être plus attirés visuellement par un ail qui a l'air beau qu'un ail qui a l'air pas beau. C'est un peu là-dessus qu'on joue.
Merci. Don't forget to put your votes in for the People's Choice Award. You get a say in who wins this competition. So don't forget to click that link and vote. Next, I have a question for Anaban. Is your work applicable for climates outside of the Arctic?
Sorry, I was muted. Sorry. So the question was, is my work applicable for outside the Arctic? Yes, because that was like the thought process behind it. Like you want to have a more wide scale assessment and monitoring response. It's more important for the Arctic because, you know, it's shared by a lot of countries and it's a very unique ecology out there. So if we lose that, we are really doomed. And that influences a lot of climate change parameters. So yes, these methods are also applicable for other soils in other regions. Of course, you would have to fine tune some of the stuff based on temperature and, you know, soil properties, but yeah, it's broadly applicable. Yes.
Interesting. Question for Deanne. What does your platform do? Can you describe an activity that children do and how they can incorporate this into their life, whether they're in school or at home?
So the first question was, what was the platform?
Yeah.
The platform, we initially had it as an iOS application. And then because we had challenges with families having an iPad, or maybe they had a tablet, or maybe they had an iPad, but the iOS was old, the system wouldn't support it. We're now moving to a progressive web app. And so that will make it available more widely to people, regardless of what platform it's. They won't have to have an iPad, and it won't have to be updated constantly. And then the second part of that question was, I'm sorry?
Can you describe an activity that children do and how they incorporate this into their life?
Yeah, so it was, the parents were told to treat it as a book. So because it was on a tablet, the parents were seated with their child and they were just supporting it. So they would talk about it like it was a book. So when pictures came up, the word would come up and the child would have to touch the picture that goes with the word, and it was completely child controlled. And so it was in a sense like a book and reading a book. And so it mimicked the essential components of reading a book, of having a parent sitting there and discussing it. Oh, if a picture came up of, a child running, it would be, oh, you like to run. And so they could talk about their shared experiences with it. And so it was trying to be as natural as possible and in mimicking that type of environment.
Interesting. So just a note, you have another 3 minutes to vote in the People's Choice Award. If you hadn't made your vote yet, go ahead and do it right now. Once the deadline closes, just like the competitors, 1 second too late, your vote doesn't count. Question for Natalie. Is there anything special about the toads or where they live that makes them ideal for studying animal movement?
That's a great question. So first of all, the species is called Fowler's toads. So they're actually endangered. We can only find them in Ontario. That's not why I study them particularly for this project, but we have conservation attempts to keep this population alive. So that's one thing. But the study site where the toads are found, so these movements that they make are confined to a really narrow beach stretch. So that eliminates a lot of variation from west-east movements. So it allows us to just like simplify the study system in a sense. And also they're pretty easy to find. And a good thing about having a large sample size, you have a higher statistical power when you're trying to prove certain theories or test for certain theories. So that's why we love our toads.
Thank you. Next, a question for Trevor. How do you envision your platform to be used in surgical education? Would it replace the resident's practical experience or be a module required to be completed before the practical experience?
Obviously, it's never going to replace a fully practical experience. Seeing a body for the first time while you're working on it is a pretty unique experience that all surgeons should definitely go through. It would be wonderful if one day my work could be used to be some sort of testing to confirm that a surgeon is ready to proceed to work on a real person. That would be my personal dream goal of it.
Nice. Question for Brad. How often are you using the eye tracking software and in what context? Is it only when people are searching for health information or any type of information? Do you do this in a lab or is it on their home computer?
Yeah, good questions. So being from the Department of Kinesiology and Physical Education, so my focus is primarily definitely on health seeking. This certainly is broadly applicable as a methodology towards other information, political stuff, seeing how people information seek about that as well. But my personal focus on research is on health. In terms of the platform, so the eye tracking software, like it's a camera we have on our own system, so they need to come to us. We can't, unfortunately, put it on their own computer. We try to, erase the cookies, try to make our computer as bare as possible to mimic an authentic internet experience, even though they don't have their own computer there. So it'll be a little bit different, but we do our best to try to make it feel natural as they're seeking information. Thank you.
Okay, thanks. Question for Ida. You mentioned that you captured the repair chemicals from stem cells allowed to grow in a 3D model. How similar is this grown 3D stem cell culture to the heart cells which we all have in our bodies? And what does it mean for the future of cardiac research?
Yeah, so thank you so much for this question. It's actually a really cool one that I love to talk about. So first of all, for this project, for my thesis, what I did is I put the stem cells in a 3D environment. And what this does is that it actually forces the cells in this kind of more close environment to become a little bit more differentiated. So they express a lot of cardiac markers or, heart cell markers. And my hypothesis was that they would produce more regenerative oriented secretome or little particles that would then heal the heart cells. So that was actually a correct hypothesis that proved to be true. Another project that I do in my lab does something very similar, but we actually make the stem cells into heart cells, and those are really, really similar to what we have inside of us. They're a little bit immature, but they do have the kind of physiological features of normal cells. So this is really, really cool. Thank you.
Very cool. A question from Natasha. Have there been any tests with the device that you patented on the individuals? Were there any comments about the wearability of it?
I wish it was wearable, but unfortunately at this time it's not. Right now we have done tests on a couple living people, comparing it to an elasticity measurement tool, but we are in the works of working on cadavers for it as a pressure measurement tool. So we're comparing it to that bladder pressure I mentioned previously. In the future, my dream is to see it as a wearable technology where you could go for a run and track your intra-abdominal pressure while you exercise. So a physiotherapist could say, okay, this movement is causing problems. Thank you.
Okay, good. Question for Emily, this time in English. Practical question. How can we tell if the garlic we are buying in the store is fresh?
Garlic is always dry, so when we collect it, it's fresh, and then we dry it for about 3 weeks. Then it's only by palpation, I would say, because the more old your garlic is, the more dry it's gonna be. So the cloves inside your bulb is gonna lose the water, so it's gonna shrink, and then you won't be able to use it as much.
Okay, thanks, Emily. I know when I was in one of the training sessions trying to help people improve their presentations, I noticed sometimes that a presenter will stand up, they start talking, and after 3 minutes, they just stare at the ceiling and say, I just realized what I should have been doing with my research is this. So a question for anybody, has participating in the 3MT competition actually changed about how you think about doing your research? Any takers for that one?
I can go.
Anavan, I see you. Yes.
So like when I first started, like environmental research, like there's a lot of things that you can study, right? So I was a bit, judging like which one to go with. I think when I started 3MD, that was the time when I started like, I was practicing these studies, and then I got good results, and I was starting to develop, okay, this is what I have to do and stuff. So I was doing a bit of research, and I found out that, connecting these two things would be indeed something good. It's simple, it's very logical, and it's very applicable. And these are also the 3 check marks on the 3MT. So it's kind of works both ways. So yeah, that's definitely helped me. Yeah.
So for anybody else, did it change the way you think about your own research?
I can answer it as well.
Yeah,
in my case, it was more thinking about the research in a broader perspective, because when you're doing science, usually, you're looking at something with a really narrow view. You're thinking about testing one single variable. You're thinking about your species alone. You sort of forget how you'd want other people to see your research. So this made me think about it in a broader scale. How does this adapt to other people's research? How can I collaborate with other people to, improve on everything that this research says? Thanks.
Anybody else want to jump in? Everyone's nervously awaiting the results. Shiman.
I can add a bit. I think it's not about research, it's about the way to communicate. Because when you're studying your PhD, you learn how to write, you learn how to do experiments, but you barely have the chance to practice public speaking. And it's important that when you communicate, especially English is not my first language, so it takes a lot of effort to practice to improve your English. So I found by participating 3MT, it really helped me to practice my speaking, and plus there's a bonus. It helped me to think deeper when I talk to people. And because I talk to people about my research, and every time I practice it, I think deeper about, so what? So that helped my research. But I feel I benefit more by practicing speaking than going deeper to my research. I don't know if other people have the same feeling as I, because I'm an international student, and the first year I come here, my English speaking was horrible. I know how bad it was, and see how big my improvement was. I mean, if my colleagues are here, they'll agree with me. So yeah, that's what I felt.
Good. Yeah, they say that one of the best ways to learn a subject is to teach it to somebody else.
Yeah, exactly.
So a question for Natalie. What have your told you so far in terms of large-scale trends? Anything of note?
So far, just to keep it short, the trends look like they move at random. It looks like it's really hard to tell what's driving their movement away from a source. In terms of what we're testing, for example, the density at a site, the resources at that site in terms of food and mates around. But it seems like they move more closely to, particles in space, like you would have equations that you would use in physics apply better to our toads than equations we use in ecology. So it kind of changes your perspective on how we should see ecology as complex systems. Maybe we should go back to fundamentals and use those fundamental equations. So that's a good question. Thank you for that.
A question for Soyun. Why did you choose to study cows? What are the implications of studying cows for the general human population?
That topic actually was given to me, but bovine mastitis is actually one of top hot topic in dairy industry, not only dairy industry, overall agriculture, because it causes huge economic loss. Like in Canada, like $600 million every year, we're losing money because of bovine mastitis. So that's the one of reason why we picked this topic. And the topic, the pathogenic bacteria that I'm working on is actually pathogenic not only for not only in animals, but also in humans as well. So there is a like host switching event between them. So if you study the pathogenic bacteria that I'm working on, actually you're actually using that kind of information to human as well. So that's why we are studying dairy cows and mastitis.
Nice. A question for Ida. If the hope is that particles will create new heart tissue, will that tissue replace the dead tissue from the heart attack, or just attach at random locations in the heart?
Yeah, so actually the idea is to inject it. So to recap, when we have a heart attack, a part of the tissue dies and it's in a very specific location, and it could be seen basically by whoever's looking at it. So the idea is to inject these cell-produced drugs into the tissue around the dead tissue, and that will kind of stimulate the cells around the dead tissue to start growing and basically replicating, and eventually it'll try to kind of minimize and replace this dead tissue. So that's kind of the idea.
Nice.
Thanks for the question.
Next question for Deanne. With the children in your study, have you seen any improvement in writing, words or letters, jointly with the improvement seen in reading?
Oh, that's a great question. And we didn't look at writing, but that would be a great thing to look at. A lot of, like with hyperlexia, it's really based around reading, and some researchers have looked at writing, but I didn't personally, and it would be a great next step. You've just given me a great idea. But
Okay, I should point out, these are not my questions. So when you're telling me they're good questions, I'm not taking the credit for these. These are submitted through the YouTube link. Question for Bradley. When subjects comment on their own eye tracking data, are they surprised by their own pattern of searching for and verifying information? How different are subjects' perceptions of their search habits compared to reality?
Yeah, great question. So unfortunately, like via the pandemic situation, data collection on this has been slow. So I don't have a ton of experience actually like having these conversations as of yet. So in terms of how their perceptions change their behavior, one, like the conversation I have with them, right, they're watching what they looked at and how they tracked it live. So it's kind of like self-fulfilling in a way, like they're watching it and in their brain, it connects with what they did at that moment. Right. So like live, it's very easy. If they didn't have the aid of their eye tracking data in front of them, I think many would have much bigger gaps in perceptions. Like the eye tracking is what gets us those gaps to be smaller. People become more conscious about what they were doing when they're seeking information, when their process is right in front of them, you know, kind of measurably. Thanks for the question.
I see judges reappearing. I take that to mean they have finally been able to rank everybody. So I'll take one last question. Deanna, are there any other hormones that could be involved in the disparity in plaque severity?
Yes, there can be many hormones that are involved in plaque severity. So like I said, my project is examining specifically sex hormones. And obviously there's not only estrogen that plays a role in sex hormones, we have testosterone. And we're also looking at their precursors of estrogen and testosterone, which is androstenedione and dehydroepiandrosterone. So we're looking at a lot of different sex hormones that may play a role, and we're hoping to see some really cool results. Thanks for the question.
Okay, thanks very much. So I think that's the end of our question period. So avant que j'annonce la victoire, il y a beaucoup de personnes à qui nous devons donner un gros merci pour l'événement aujourd'hui. Planning this event started in September, and it really takes a large team from McGill to make it happen. First of all, the team from Skill Sets and GPS, including all those who assisted with the training sessions and event planning, especially April Baby. Kat Balil, Alex Leping, Mary Jo Rahal, Sajana Arachilaj, and Andrew Churchill. Davis Hepner for designing the event program. Our fantastic tech team for running the live stream event today, Stu McCombie and Jonathan Roy. All of the other McGill staff and students who gave the competitors feedback throughout the process and helped select the finalists during the qualifying heats. The support from alumni relations as well as communications and external relations team. Our judges today, who I'm sure had a very challenging task selecting the winners. And of course, we must thank all of the students who had the courage to present today, including all the 150 who didn't make it this far. Vous nous avez éblouis par votre passion. Félicitations à tous nos finalistes pour la qualité de la présentation. Please give all of these folks a big round of virtual applause. At this point in my program, I see that I'm about to invite Josephine Nobantaglou from GPS, but unfortunately she couldn't be here. So I get to take the credit for announcing the winners. So we'll begin with the People's Choice Award. The Prix du Public est Lisanne Deanne. Third prize goes to Natasha Jacobson. Second prize goes to Ida Darish. Le ou la lauréate de volley francophone qui représentera McGill à la finale nationale du concours ACFAS, la thèse en 180 secondes est Oriane Canes. First prize, representing McGill at the CAG's Eastern Regional 3MT Finals, is Trevor Cotter. Congratulations. Can we please have a one last round of applause for all the finalists? They've all done a fantastic job today. And for the judges. Merci beaucoup tout le monde et bonne soirée.